Ever look up at the night sky and just, I don't know, get kind of overwhelmed? Yeah,
Overwhelmed.
like all those stars, right? Some of them have been shining for, what, billions of years?
Yeah,
It's almost impossible to wrap your head around.
I know what you mean. It really puts things in perspective.
Exactly. And today, we're going to dive into the story of one particular star that really drives that home.
Oh, yeah. What's that?
HD 140283, nicknamed the Methuselah Star.
Ah, Methuselah Star. Now, that's a name that gets thrown around a lot in astronomy
For
circles.
good reason. It's one of the oldest stars we've ever found, a real glimpse into the early universe.
It's located about 190 light years away,
Yeah.
right? And if I remember correctly, initial calculations put it at something like 14.46 billion years old.
You got it.
Yep.
But here's the thing. The universe itself is only about 13.8 billion years old.
Wait, hold on. A star older than the universe, that doesn't make sense.
Right. It's like saying you found a chicken bone in a T-Rex fossil. Something's got to be wrong with that picture.
so,
Uh,
so how do we explain that? Like, what are the possibilities here?
Well, that's exactly what we're going to unpack today. We're diving into the source material on the Methuselah Star, trying to figure out how this is even possible.
All right, I'm in. Let's do it.
So you've got the star, right? It's a subgiant.
Okay, subgiant, meaning it's starting to run out of hydrogen fuel in its core. We see that a lot with older stars.
And one of the first things that jumped out to scientists was its metal content, or I guess the lack thereof.
Ah, right. It has a very low metal content, which in astronomy speak means very few elements heavier than hydrogen and helium.
So for our listeners who might not be up on their astrophysics, can you break that down for us? Like, what does the metal content tell us about a star's age?
Sure thing. So basically, the early universe, right after the Big Bang, was pretty much just hydrogen and helium. It was like a blank canvas.
Got it.
And as stars formed and went through their life cycles, they started creating these heavier elements through nuclear fusion, the stuff that makes up planets and, well, us.
So the more metals a star has, the younger it is.
Yeah, pretty much. It means it formed later after previous generations of stars had already seeded the universe with these heavier elements.
So HD 1402A3, with its super low metal content, is basically telling us it's from a time when the universe was still pretty much in its primordial soup phase.
Exactly. A true relic from the early days, which makes that initial age estimate even more perplexing.
So how on earth did they even get that 14.46 billion year figure? And more importantly, how did they end up revising it down to something a bit more believable?
Well, it all boils down to how we measure the ages of stars. It's a pretty complex process, and there's a lot of room for error, especially with stars that are so far away.
Error and what?
Well, a lot of things, actually. Distance is a big one. The further away a star is, the harder it is to accurately measure its distance, and that can throw off all sorts of calculations.
So how do you even measure the distance to something that's like hundreds of light years away?
Well, there are a few methods. One is called parallax. It basically uses the Earth's orbit around the sun to create a tiny shift in the star's apparent position, and from that you can triangulate its distance.
Tricky.
It is. And with older methods, there was a lot more uncertainty in those measurements. But more recently, thanks to space telescopes like Gaia, we've gotten much, much better at measuring parallax.
True.
Yeah. It's a European Space Agency mission launched back in 2013, and it's been mapping the positions and movements of over 1 billion stars in our galaxy. It's given us the most precise stellar map ever created.
Wow.
Yeah, it's incredible. And that data has been crucial in refining our understanding of the distances to stars, including Methuselah Star.
So Gaia helped us get a more accurate distance, which then led to a revised age estimate.
Exactly. It's like having a better ruler, you
Yeah.
can measure things more accurately.
Makes sense. So that explains the distance part, but you mentioned other factors too, right? What else goes into figuring out a star's age?
Right. Another big one is a star's brightness, or luminosity. The brighter a star, the faster it burns through its fuel, and the shorter its lifespan.
So a dimmer star will generally live longer.
Right. And then, of course, there's the chemical composition, like we talked about before. The metal content gives us a clue as to when the star formed.
So they took all that, the refined distance from Gaia, the brightness, the metal content,
Yeah,
and plugged it into some kind of model to get the revised age.
exactly. And the models themselves have improved over time, too. We've gotten better at understanding the physics of stars and how they evolve, so we can make more accurate predictions about their ages.
So we've gone from a star that seemed older than the universe to a star that's, well, still incredibly old, but at least makes sense within our current understanding of cosmology.
Precisely. It's still one of the oldest stars we've ever observed. around 13.7 billion years old, which is absolutely mind-blowing when you think about it.
Yeah, this star was around when the universe was just a baby, like a cosmic toddler.
And that's what makes it so valuable to astronomers. It's a direct link to those earliest moments of the universe.
Like a time capsule, right? Telling us what conditions were like back then.
Exactly. And by studying stars like Methuselah Star, we can start to piece together the story of how our universe evolved, how those first stars and galaxies came to be.
It's amazing. And it makes you wonder, if we've already found a star this old, what else is out there? What other ancient stars might we discover that could push the boundaries of our understanding even further?
It's a tantalizing thought, isn't it? I mean, we're constantly making new discoveries, finding new objects in the universe that challenge our assumptions.
It's a reminder that we're still just scratching the surface of what's out there. So much left to discover. And who knows what incredible secrets are waiting for us in the depths of space.
Well, one thing's for sure, it's going to be a fascinating ride.
Absolutely. Thanks for taking this deep dive with me.
Anytime. Always happy to talk stars.
Until next time, keep looking up. You never know what you might